So we've talked about voltage. In the past, previous section, we've talked about amperage or current. So now how does that all tie together? Well, what we have up in the right corner is a simplified diagram of what an electrical circuit would look like. We have the battery. The electricity goes out of the negative side of the battery into a switch commonly. That switch is just a removable piece of metal that if it's removed, like in the position it's in, electricity doesn't get to flow to the lamp. If we were to close that switch and push it down, then electricity would get to flow through the lamp, it would light up the lamp, and then it would go back into the positive post of the battery. Now we're not going to look at actual diagrams of circuits, we're going to look at simplified diagrams or schematic diagrams. So the schematic diagram below is a simplified version of it. So we have the battery. We do have to identify the positive and negative posts. The way we do that on the actual diagram itself is with arrows. Always the electricity will be flowing out of the negative post and into the positive post. A switch is represented by just a gap that's open. It may be closed as well. And the lamp is just a circle with what looks essentially like a light bulb filament in it. So then what happens as the charge moves through the device? We can start adding elements to this circuit. So we've got the same circuit here, but now we have a voltmeter. A voltmeter measures the potential difference between 2 points. It measures the voltage. A voltmeter always has to be connected across a device. So in the schematic, we would have one connection on one side of the lamp, one connection on the other side. We could never connect the voltmeter in, let's say, point B and this point here. We actually need to measure the voltage difference between before the device and after the device. So a voltmeter will always be connected that way. That's called connecting it in parallel. And a voltmeter is represented by a circle with a V. The other kind of device that we can connect in is an ammeter. It measures the current that's flowing through a circuit. So unlike a voltmeter, an ammeter is connected in series. It's just connected in line with everything else. So we have our battery, our switch. The ammeter does not need to be put across a device. It goes in line. We have the light bulb off to the right, and I've omitted it this time. But if we were to have a voltmeter, we would have to connect one side on this side of the lamp, one on that side of the lamp, like so, and a V for the voltmeter. So this is what a basic schematic diagram looks like. All we'll ever have to deal with are batteries, switches, meters, and something we'll deal with in a couple sections in the future called resistors. I'll just give you a preview of that. A resistor is something that actually slows the flow of electricity down. They've got multiple different uses, but we'll get to that in a few sections.